Welcome everyone. In this video lecture, we'll learn about efficiency of half wave rectifier and we'll also learn about peak inverse voltage of half wave rectifiers. So what is rectifier efficiency? So the ratio of DC power output to the applied AC power is known as rectifier efficiency. The ratio of DC power output to the applied AC power is known as rectifier efficiency, and it is denoted as eta. So rectifier efficiency eta equal to DC power output divided by input AC power. Now we'll calculate the efficiency for half wave rectifier. This is the diagram for the half wave rectifiers, and this is the output. This is the graph for the output of the half wave rectifiers. Suppose the voltage appear across the secondary winding transformer be Vm sin theta due to this AC supply, and RL be the load resistance, and RF be the diode forward resistance. So for calculating the rectifier efficiency, we have to first calculate the DC power output. Now coming to DC power output. Now come to DC power output. So as you know that the output current of the half wave rectifier is pulsating in nature, that is some amount of AC that will be mixed will DC, so it will not able to get pure DC. So in order to find out DC average power, we have DC power, we have to first calculate the average current. So average current I average equal to IDC equal to area under the curve over a cycle divided by base. So how we calculate the area under the curve over a cycle? As you see, if you take, this is the output curve for the current in case of half wave rectifier. As you see, if you take the small portion of this curve as d theta and integrate the current I over d theta, will able to get the area under the curve. So area under the curve over a cycle is integration of I d theta 0 to pi, limit is 0 to pi, divided by base is 2 pi. That means for one cycle. So we will rearrange the term 1 by 2 pi integration 0 to pi I d theta. As you know, the current flowing through the diode is Vm sin theta divided by Rf plus RL. So this Rf plus RL is the total resistance of the circuit. Rf is the diode forward resistance and RL is the load resistance. So total resistance of the circuit is Rf plus RL, and the voltage is Vm sin theta. So V by R equal to I. So 1 by 2 pi equal to so the term will become 1 by 2 pi integration of 0 to pi Vm sin theta divided by Rf plus RL d theta. The I will be written as this Vm, this term Vm sin theta divided by Rf plus RL. Now if Vm divided by Rf plus RL is constant, so we will taken we'll taken this term to outside. So Vm divided by 2 pi Rf plus RL integration 0 to pi sin theta d theta. The integration of sin theta equal to cos theta. So Vm divided by 2 pi Rf plus RL minus cos theta. Integration of sin theta is minus cos theta, lower limit is 0 to upper limit is pi. Now the expression becomes Vm divided by 2 pi Rf plus RL minus cos theta plus cos 0. So Vm divided by 2 pi Rf plus RL, cos pi, the value of cos pi is minus 1. So minus of minus 1 plus 1. So this will becomes 2. So 2 will be cancelled out. Now the expression will becomes Vm divided by Rf plus RL into 1 by pi. So Vm divided by Rf plus RL is peak current, that will be represented as IM. So now the expression becomes IM divided by pi. This is the value for the average or DC current. So average or DC current, I average or I DC is IM divided by pi. Now the average DC power will be calculated as you see, the DC power PDC equal to we know that power equal to I square RL. So power PDC equal to IDC square into RL. IDC is IM divided by pi, pi whole square into RL. We will taken as this equation as equation 1, this expression as equation 1. Now we will calculate the AC input power. The AC input power is given by PAC equal to I RMS square into RF plus RL. PAC equal to I RMS square into I RF plus RL. For half wave rectifier, I RMS is IM divided by 2. So putting the RMS value in the above equation, in this equation, PAC equal to IM divided by 2 whole square into RF plus RL. This will be taken as equation 2. Therefore, the rectifier efficiency is DC output power divided by AC input power. The DC output power is IM divided pi into whole square into RL. We'll put this from equation 1, and AC input power is IM divided by 2 whole square into RF plus RL from equation 2. So the expression becomes IM square divided by pi square into RL divided by IM square divided by 4 into RF plus RL. I will cancel the IM square will be cancelled out. Now the expression becomes 4 divided by pi square into RL divided by RF plus RL. The value of 4 divided by pi square is 0.406. RF plus RL divided by RL. We will just rearrange the term, the RF plus RL divided by RL. Now the expression becomes 0.406 divided by RF plus RL. So the efficiency will be maximum if the RF is negligible as compared to RL. The efficiency will be maximum if you will get the maximum efficiency if the RF term, diode resistance, forward resistance term will neglected in comparison to the load resistance. So the maximum efficiency becomes 0.46 if you calculate the percentage of maximum rectifier efficiency. Will multiply this term with 100 as you see in this case, and will get the maximum rectifier efficiency for half wave rectifier is 40.6%. So what does it mean that maximum efficiency for half wave rectifier is 40.6? That means that in half wave rectification, a maximum of 40.6% of AC power is converted into DC power. Out of 100% of AC power, only 40.6% is converted into DC power. I hope you will understand the rectifier efficiency for half wave rectifier. Now come to the PIV or PRV for half wave rectifier. We have already discussed this term. PIV means peak inverse voltage, or PRV means peak reverse voltage. The peak inverse voltage is the maximum reverse bias potential that can be applied before entering the breakdown region is called PIV or PRV. We have already discussed this definition. Now for calculation of PIV for half wave rectifier, this is the circuit diagram. As you see in this case, the maximum supply voltage is VM, the minus is this side and plus is this side, and this will be the load resistance. The current through the circuit is 0, and in the reverse, as you know, in the reverse bias case, the diode is open, so there will be no current flowing through the diode, so it will act as an open circuit. So in place of diode will represent as open circuit, and the output voltage across the load R is V0 equal to IR. The current flowing to the current flowing to the circuit is or resistance is 0. So if you put I as 0, so 0 into R equal to 0 volt. So output voltage is 0 volt. Suppose take this PIV voltage as V. Now applying KVL to this applying KVL to this circuit, Now Vm minus V0 minus V equal to 0, as V0 is as 0, so Vm equal to V, so V equal to Vm, so peak inverse voltage is equal to Vm, as we take PIV as V. So so for half wave rectifiers, the peak inverse voltage PIV must be greater than equal to Vm. For half wave rectifiers, the PIV must be greater, the peak inverse voltage must be greater than equal to Vm. As you see in this case, the peak inverse voltage for half wave rectifier must be greater than equal to Vm, maximum supply voltage. I hope you understand about the peak inverse voltage for half wave rectifiers. Thank you very much. Thank you for your patience.